Hallo en welkom hier so by Farmspace, die Horsch fabriek in Schwandorf. Ons kyk hoe word kwaliteitbeheer toegepas. Philip vat ons deur 'n paar ander plekke. Moenie hierdie mis nie, kyk hier deur. Dit is regtig 'n awesome fabriek daai.
On this premises, our manufacturing process is painting, assembly, logistics. There's no mechanical steel fabrication happening here. You saw it in Ronneburg yesterday.
Yep.
We do about 25% to a third of our metalworks ourselves in Ronneburg, and you've seen it yesterday. There's no mechanical or metalworks happening here.
So
Just painting,
you give them the
logistics.
dirty jobs and you do all the clean jobs here.
Yeah, sort of. So since this is our headquarters here, we have all our central services placed here, whether it's, financial department, sales department, service department, parts, production planning. We supply our parts out of a fully automated parts store and working basically two shifts on a two-shift scheme here all around the year. And parts get shipped. Every service part, every wear part that is ending somewhere around the world is starting here in this area. So this is a fully automated parts store where about half of the parts store is equipped with crates and pallets, and the other half is equipped with boxes. And it's a manless store, fully automated, so the parts get to be supplied to a picking area outside, and then people take out parts or put parts back into boxes or crates to be put into the shelf again.
And that basically, that automated robot there
Yeah,
does the job.
picking up a crate or picking up boxes, supplying boxes to the outside. And when we look at the picking area here, what we do is we don't work with descriptions and part numbers anymore. We work with pictures. So every part is being pictured, photographed, and the guy who is picking out parts and commissioning the parts into a service supply job, he's actually looking at a picture of the part on the screen beside him, and then he easily can see if he has the correct part in front of him. Less mistakes. And he just has to look at the picture and he has to count. He's shown a number, so he counts, and that everybody can do. Less mistakes.
But I'm pretty sure it still also has a number, but primary is now the picture.
Yes, of course.
Oh.
Of course. In the background there's numbers, of course.
Yeah, I just want to check here quickly.
So if you keep standing there, every once in a while the brakes don't work, so it slams against the back wall. So I have to watch it.
And it's pre-programmed to know that every crate has got like a barcode on it too.
No, he doesn't need a barcode on the crate. He just knows where the location is. He doesn't look at barcodes. And you can imagine when he picks up a part back there, it takes a lot longer to take it to the front than if he took a box out there, right?
Yeah.
And that's why the parts store is permanently reorganized. So the fast movers are slowly moving to the front, and the slow movers are placed way in the back, automatically, by software.
That is so interesting.
But you'll see something more interesting in a minute. That is, this technology is state of the art since 20 years, and we have another parts store in another building that is the latest state of the art. Very interesting. You'll see. So every service part that goes around the world and somewhere is moving out here. Every single one.
Every single one.
Every single one. Typically, our production is here in Schwandorf the same as you have seen in Ronneburg. So the majority of production is working in line in a sequence way, and some of the production is working in a nest, where the machine is not moved.
Yeah.
And Something that is special here in this line is producing all the kits that go into containers. So for example, if a container ends up in South Africa, most likely it's built in this line. So you see, for example, back there a package packed up for a container to be shoved in a container back there. Or here, this is also a package being configured for a container. So it fits in a container. We load around 4 to 5 40-foot containers every day. 4 to 5 40-foot containers every day. This year, around 800 containers. Typically, in an assembly process, as you have seen before, there's sub-assemblies being done on a componentry level and then being supplied to the final assembly stages. This, for example, is a sub-assembly for bins, for tanks, and then they get supplied to the line to be married with the machine, with the chassis. And of course, every individual tank that is being assembled here, has its own specification. Everyone is different. Everyone is different. This again is a line assembly, and from the side there's all the sub-assemblies being supplied to the line, to the final assembly. Right now they are building avatars, but this would be also the line where we built the large maestros up to 18 meters in width.
Yep.
So when there's a large maestro above 9 meter ending in South Africa, it's going to be built. It's always being built in this line, in this specific line.
So this is where every maestro is born.
Yes, the larger ones. Smaller ones are in Ronneburg, as you've seen yesterday.
Yes.
There was, so this part is the logistical part, where all the parts are being commissioned for every individual machine. Everything is commissioned individually because every machine is different.
Yeah.
Different specifications, different options, etc., etc.
But I mean, at the end of the day, when I, as a farmer, I've got a specific need, and I'm telling you, I want this and this and this, and in my mind, it's easy.
Yeah.
But you have to figure out how do you put that machine with that different configurations and everything through the assembly process without screwing up the assembly line.
Well, as long as the specifications are within our price list options, it's easy. It gets a little bit more tricky if there's an individual question, just a simple one. I tell you a very simple one. A customer says, you know what, I have a special tractor in the front. I need longer hoses, longer hydraulic hoses. Can you do for me each hose at the front be 1 meter longer? We would do that.
And it is something that sounds so simple, but to actually get that done on scale is where the challenge is.
Yes, exactly. So this is a totally different storage and logistical handling system as you have seen before. The way it works, it's so-called auto-store system. The way it works is there's plastic boxes like beer cases above each other, 17 above each other, okay? And when you want to take out the bottom box, one of these robots has to dig down. Take a box, put it to the side. Take a box, put it to the side. Take a box, put it to the side. Till he has reached the box he wants. And then he brings the box to the outside, drops it down, and the person can pull a part out, right? Or put a part back in, right? The advantage of this system versus the other system you've seen before is obvious. Very dense stacking, no aisles, nothing. So this is the densest way to stack parts. Very dense. Plus, in the system you've seen before with an aisle and a handling system, there's only one handling system in one aisle. So there's a limit in dynamics, in frequency.
Yeah.
Here, if you need more frequency, you put more robots on top. 5 more robots, 5 more frequency.
And they know where each other are. They won't bump into each other.
It's all software. It's all software. It's all software. And this is a system you can put in any building, inside any building. You don't build an extra building for it because it's not that tall. The size of this, the storage capacity is just the same as over there. With only the box side, only the half. You know, the aisle is
Yeah.
only that. And we actually commission We commission even small parts. I mean, look what's in there. Small bolts, special bolts, nuts, pins. We commission every single assembly part out of this store for the complete factory here. So this one store supplies all the assembly parts.
Every single thing.
Every single part gets commissioned for every single job, for every single implement.
Okay, so then number 12 is now putting it down so that they can basically fetch the part, whichever they need to get there. And there goes number 8. So he's now going to, I'm guessing, shelve that box. Okay, let's see what number 8 does now. So there's constantly orders coming in, and they it's like a, so the robot will stand there, okay, right, what is the next order in line, and then it would most probably see which robot is closer. And
this storage here runs on 2 shifts all week around, and if we are very busy, it runs on 3 shifts.
And I'm guessing these things all battery powered, and when they run out of battery, they can recharge there.
Exactly.
I've learned that from the Husqvarna Automowers.
Yeah.
So I'm almost guessing it's the same thing. And maintenance on these things? I mean, how long have you been running the system?
For now, 14 months. Nothing.
And it's literally going like this.
Yeah.
While
since
there's people.
14 months.
So that's the picking stations. That's awesome. Hydraulic hoses.
So what we see here, this is a fully automated assembly station for our hubs.
Yeah.
You know, we have hubs in our chokers, in our prontos. Everywhere where there's a disc on, we need a hub. You know, and the hub is being put together, made out of a spindle, a bearing, a lubricant, a seal, and the hub itself. And what we see here is a fully automated assembly station for our hubs. Typically we have about 4 different types of hubs, and all 4 different types can be assembled here, fully automated. The advantage of a fully automated station is quality, not cost. We always think cost.
Yeah.
Actually, this doesn't bring us yet a cost benefit. It's not less expensive than doing it manually like we did before, because the investment is so high. But long term it might.
But it does up your quality.
Incredibly, because every single stage of assembly is 100% controlled, and you can actually build in controls which you never can do in manual processes. I'll give you an example. When you look at here, where the individual parts are being picked up, right, from these robots, spindles, hubs, bearings, etc. Every single part, before it goes into the line, gets measured, and then the outcome you can see here on these screens.
Oh, so it's actually measuring every single thing.
Every single part with an optical measuring device. So, for example, here you can see the last part that he's measured is 30.0000 millimeters, up to thousands of a millimeter preciseness. Not only that the diameter is measured, also the roundness. And if there's a small tolerance not being met, gets thrown away right away. And in a manual process, you would never even detect a part that is just a little bit off.
I mean, I can't measure that with the vernier. That's
exactly
impossible.
No way. Exactly.
So it's measuring in.
See the next one. 3,000 of a millimeter difference of that part.
And that's fine. That's still.
I think it's still okay. But and then of course, when there's a nut being tightened in the process, every single nut is documented. At the end, every single finished hub unit gets a barcode, so we can actually detect afterwards if we have a serious problem. We can say, okay, there's a batch of these and these things. Okay, they went into this and this machine.
You can recall it.
Yeah. Only this one individual batch. But in the end, you don't have recalls anymore because there's no mistakes in a system like that. There is 0 mistakes, zero.
And that one is now 0.001.
0.1. Yeah.
But maybe you can see that every single one that was 0.003, we thought that tolerance was good, but it's not good enough, for example.
Yeah.
But
and
that's
of course,
the type of things you only find out over time as well.
For example, you have a spindle where you where you press a bearing on, right?
Yeah.
And there is a force that is required to do that. In a manual process, it is very difficult to measure this force precisely.
Because it's usually done with a hammer.
No, not with a hammer, with a press, let's say. In a fully automated process, you very precisely measure the force, and likewise, you can then, of course, detect if even a bearing is out of tolerance, or the matching tolerances don't fit as well. And in that way, you can 100% control quality, 100%. Zero mistakes anymore.
Oh, that's awesome.
Zero mistakes.
Okay, let's sien hier. So is chassis wat ook wag om uit te gaan. Ek dink kyk net hier. Die kwaliteit op hierdie goeder, seker.
So we are now approaching our newest addition here on this site, which is our paint facility. So that whole building is a paint facility.
This whole thing.
1.2 hectares.
So it should say the paint shop.
Paint shop. 1.2 hectare paint shop.
1.2 hectare paint shop.
Yeah. And
1.2 hectare se verf. Jo.
And we are at the moment getting everything fine-tuned. Final paint production will start in probably 2 to 3 weeks. So they're still, doing test runs.
So we're seeing this now before it goes into
before
production.
it goes into production. Doing test runs, calibrating everything, testing every individual step in the paint process, etc., 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 etc.
So this is now Ronneberg's paint facility on steroids.
Exactly. Big steroids.
Big steroids.
And so, like always, highly automated, fully automated washing process, highly automated powder coating process. This chamber, for example, here is a hand chamber. There are certain parts you can't do
Yes.
run through the automation process. You can do by hand. So it's glassed
Just because
in.
of the heat.
Yes, and also because of maybe sizes or certain other parameters.
limitations.
And so it's glassed in, so you can see later on what people are doing in here. You have seen something like this. This is a powder station where there's sensors around. Parts are run through here on a gantry, on a conveying belt, and then fully automated, covered by powder. And this is also our largest investment into painting in our history. Just a single investment is around 25 million euros.
Why are you doing that? Isn't the current stuff up to scratch?
Basically, we need more capacity. We doubled our revenues in the last 3 years. We just need more capacity. And with this investment and other investments, we are ready for another doubling in the next years to come.
So, question. And there's also such thing as healthy growth. But isn't that now just growing out of your boots at the end of the day? And what are the risks that comes with that? And how did you mitigate it to make sure?
Well, I still have my boots on.
You still have your, well, that's
it's still
good.
working. No, definitely not. We're definitely not growing out of our boots. It's fun, and we have everything under control. Things work really well, and the main reason for that is we have incredibly well and dedicated people that are responsible for all these individual processes within the whole system, within the whole organic organism. And when you have in your genes since 30 years just growth and growing and being flexible, being agile, and being able to move fast. Everybody has these things in his genes, and that's why we can do it. Easy.
And also making things better every
And we have never
day.
complaints about these things in our staff. They will say, "Oh, let's do it." Sometimes I go around and tell my guys, "You know what?" They ask me, "How about next year?" I say, "You'll see next year no growth." Then they start laughing. Yeah, you said it a couple times, no growth. You never were right.
We're going to relax a little bit.
Exactly.
Why did you go for the powdered painting? Why is that so important?
Very
versus
simple.
Traditional
Very
painting?
simple. We have very strict emission laws in Germany, and actually a wet system in that size, you would not get a permit anymore
Ja.
because of emissions. No way to build a wet system like this due to emission laws. And a powder system has no emissions. And secondly, what we also pay attention on is our washing process is 100% enclosed. This factory has no connection to a sewage system whatsoever. No sewage, no wastewater, fully enclosed system, no fumes, no emissions. We have to be sustainable, and we have to look at environmental topics, and that's why I invest into new technologies.
So the other thing that I saw about your equipment is we had a second-hand auction, and I was actually reviewing this thing on behalf of the potential buyers. Your machines seem to age very well.
Correct.
They still look like it was almost taken out of the factory yesterday,
Yeah.
even though the machine is 10 years old.
Yeah.
Is that also testament to your whole painting process
Absolutely.
and all those
Absolutely.
things?
That is painting. And painting is a very critical process. It requires a lot of know-how and expertise. And I can tell you, it took us years to get there. And I have seen lots of paint problems in the past with my machines, and I don't want to see any further paint problems. And paint is a critical thing. It's very difficult, and paint starts with the raw material, with the preparation of the raw material, and then with managing the processes. And it's actually not that easy to manage these processes. They're pretty complicated, especially the chemical washing process. And you actually need one person in every shift that only watches the chemistry in the washing process, nothing else.
So you literally have got basically like a chemical engineer sitting
Yes,
there,
yes.
making sure everything's
Chemistry is always right, temperatures are right, processes run right. So you have to imagine it like a dishwasher, a very sensitive dishwasher, and where you constantly have to measure temperatures, chemistry, combinations and concentrations, pressures, times, etc., etc., etc.
awesome.
Very complicated process.
I'm speechless. Right, so dit is die oorspronklike fabriek daar by Schwandorf. Philip besig om ons daar deur te vat. Kyk uit die volgende een wat kom. Ons kyk 'n bietjie die stres test, die ou fabriek gedeelte, al daai goed. Awesome fabriek. Tot volgende keer. Groete.